Memory. So the memory allocation in the SAP memory management, how the memory allocation will happen to the, so in the memory management here. It's a very important, this memory management. And also it's confusing topic also, right? So depending on the work process type, depending upon the work process type, there are the types of work process we have, right? So dialogue and so non-dialogue, dialogue and non-dialogue here. So depending upon the so work process type here, depending upon the work process type, underlying operating system, the SAP memory management decide the sequence in which the work process allocate the memory areas from the extended memory and private memory in order to process your user request, in order to process the user request. So depending upon the operating system, depending upon the type of work process, your memory management decide to process the request here. So here the allocation is slightly different between dialogue work process and also non-dialogue work process here. So dialogue work process, if I talk about the so dialogue work process here, dialogue work process here, the dialogue work process, the dialogue work process. So Windows level, suppose if I talk about the Windows level, dialogue work process, Windows level, the first it will use the extended memory. They are the memory areas in the SAP. One is the role and extended, right? Then so role extended and the private that we will also call it as the heap memory here. They are the three main memory areas in the SAP here. So extended memory, private memory, and the role area means a role memory here. So dialogue work process, as I mentioned here, depending on the type of the work process, depending upon the uh, operating system, underlying operating system, the memory allocation slightly behave differently here. So if I talk about the Windows, the extended memory, right? The extended memory. First, it will use the extended memory.
This is our time.
That is, we will call it as the EM. Then only when the extended memory is full, then it will go to the so private memory here. Private memory. Normally, private memory we will call it as the heap memory here. Heap memory here. So what is this extended memory here? Right? So extended memory. Extended memory is the main of the core of the memory management. It is the main core of the SAP memory management here. The majority of the data for the user session, which different work process access when the processing the request, so it is stored here. So the data, the first work process user related context, user specific data, the and that all the work process that has access to that will be shared into the that extended memory. Extended memory is the main of the SAP memory management. The majority of the data means for the user session. So which different work process access when the processing the request, different work process will access the extended memory here. So extended memory is mainly for the core and the user data, user sessions data, user context data, it will be used here, right? So there is a parameters which will control the memory limitations and everything. It will release it here, right? So normally, so previously we have the role area. Actually, since extended, the role area is there, but role area was removed in the NetWeaver 7.4 version. The role area was removed. Now the main area is the extended memory. In case of extended memory also the occupancy is done, then finally it will go to the private memory here. Private memory. So private memory means heap memory. Normally heap memory contains the private memory contains the data from user context. Data from the user context. It is bound to the work process within the user session. It is bound to the user session here. right? So means this is a one more memory area. So SAP in the memory management, so there are the memory areas they have divided actually. One is the extended area and private area. Role area got removed actually in the nowadays. So first it will use the extended memory. Even though this is not sufficient, then it will go to the private memory. Private memory, it will go to the private memory here, right? So in the Windows based systems, first it will use the first it will use the sorry. So in the Windows based systems, the first it will use the extended memory, then private memory here. So at the same time, same dialog work process. So non-Windows means so Unix, Linux, so AX, so yeah, Unix, Linux, AAX. So these are the so non-Windows systems. In the non-Windows systems, also the first it will use the EM extended memory, then only it will go to the private memory here. So which means dialog work process either Windows operating systems or Linux operating systems, it will behave the same. So first extended memory, it will occupy it, then it will go to the private memory. It will occupy it here. When the work process go to the private memory, then it is using the operating system level memory. Immediately at any time system will go halt status. Halt status means down status here. So that is the one important thing here. Suppose when it comes to the non-dialog work process here, right? So non-dialog work process. So non-dialog work process means here BTC, update, and spool. Only these require the memory. Remaining all are not required here, right? Normally we will call it as the non-dialog work process here. So non-dialog work process, Windows. In the Windows operating system, same extended memory, it will occupy it. In case of extended memory is is over full, then we don't have much memory in the extended memory, then it will occupy the remaining memory, that is called the private memory. It will occupy it here. Private memory, it will occupy it here. In the Linux systems, which means non-Windows systems here, non-Windows systems, only this work process will behave either differently, which means first it will use the private memory, then it will go to the extended memory here, which means background work process. The background work process in the Linux operating systems, it will reverse order, it will behave it here. Reverse order. Reverse order means first private memory, extended memory here. These are the memory areas in the SAP application server level. Private memory, heap memory. This is the allocation progress, how the allocation will happen in the each and every area. So in the dialog, first role, extended private memory, right? So role, what is role? What is extended memory? So right. So there are the memory allocation types are there here. And also apart from that, we have the shared memory also available here. Shared memory. Shared memory will use by the all the work process here. Right? It's not the user specific and it will not store any address stability and everything here. Right? Shared memory. So shared memory that shared by the all the work process. Shared memory will be shared by the all the work process here. Shared memory resource. All the work process will use the common memory, that is called the shared memory. Right? Some amount of memory is there that will be used by the all the work process will use that memory here. So that is the shared memory of the operating system here. Right? There are shared memory segments. So in the operating system level, we can see that one shared memory segments and we can clean up that shared memory segments and everything here, right? The only thing is the extended memory. Extended memory contains the user specific data, So user specific data that all the work process has access to this. That is the user specific data that will be stored into the all the work process have access to that specific data here. That is called the extended memory. Extended memory is core for SAP memory management system here, right? So then what is the private memory means? It contains the data from the user context. Memory contains data from the user context here. Data from the user data from the user context that is bound to the a work process within the user session that is allocated to the that is in the within the work process that will be allocated to the session here, right? This is the contains the user specific data. All the work process have access here. In the private memory, only specific work process will have access here. Specific work process will have access to this one here, right? So the allocation sequence, how the memory will be allocated in the windows for dialogue and non-dialogue here. So for the dialogue work process and non-dialogue work process, first it will use the extended memory. In case of extended memory is full, then it will go to the private memory. Heap area, dia, heap area, non-dia. There are the parameters for the this memory areas here, which will control the memory restrictions here. So suppose example, there is a JDTA slash roll underscore extension, roll underscore extension. This parameter will control the extended memory here. Then another parameters above heap area dia, above heap area dia, and above heap area non-dia. So these are the work process that will limit the this mechanism here. And above heap area total, this total equals to the heap area dia and heap area non-dia here. So this memory parameters, memory, whatever the value is there, it will control the memory area. These are the memory parameters here. These are the memory parameters here. Memory parameters which will available here, right? This will control it here. This will control the all the operations and everything here, right? So that is the allocation sequence will happen for the work process here. Work process, it will occupy the work process here, right? So that is the memory allocation in the work process management. How the memory will be allocated to the work process, depending upon the operating system, depending upon the your type of the work process, the allocation will happen here. Which parameters will control? These are the parameters which will control the all the work process related things and everything here. All the work process related things will control that's what here, right? So here extended memory and private memory here. It's a extended memory is a large part of the user context is stored into the extended memory. This is the main memory, extended memory. It is the main part actually in the SAP memory management. That is the main part here. All the user context is stored. User context means user related information stored, authentication, default settings, and user ID, password, everything will be stored in the extended memory, right? So that is the extended memory here. So private memory means if the extended memory is fully occupied, then work process allocates the heap memory here. Then this is also known as the private memory. In case of extended memory is not full, then it won't use the heap memory. Then extended memory is full, then only it will use the heap memory here. Then in the that is called the private memory here. So here user context no longer be processed by the different work process here. Only the private mode specific work process will process it here in this memory here, right? So that is the user context. Normally, how this memory allocation will happen in the shared memory? How this memory allocation will happen? So if you see the work process architecture, then I will show you how this memory allocation will happen, in which area this logon process work here. So this is the SAP logon pad here, SAP logon pad here, then SAP logon pad to the, you will log into the SAP dispatcher here, right? Dispatcher, this is the GUI. So this is the dispatcher here, application server level, you have the dispatcher here, right? So the request will comes to the dispatcher. Then dispatcher to, it will assign the request to the work process here. Dispatcher to work process will be assigned. There the number of work process are available here. So any one of the work process will allocate to the request. In the work process we have, they are the, in the work process we have the, each work process there is a internal memory that will occupy it here. So here in the each work, this is a work process. In each work process, inside of the work process, what will be there? Inside of the work process, we have the, so we have the screen processor, we have the screen processor, and we have the ABAP interpreter. If I go a little bit deep about this one work process inside, we go to the ABAP interpreter, then database interface. Now database interface here, right? So then here, this is the task handler here. This is the task handler here. Task. So task handler here. So this is the each work process. This is like this only here, right? So first SAP GUI. This is the GUI. SAP GUI part here. This is the GUI. SAP GUI here. So GUI. So GUI, SAP GUI. So GUI to dispatcher. Request will comes to the dispatcher here. Dispatcher will maintain the all the request into the FIFO order, first in, first out order. So dispatcher has the mechanism to maintain the, so FIFO order here. Then once the FIFO order maintained, then request will go to the work process here. So one the work process here. The step number 3 work process here. It will come to the dispatcher. Dispatcher will maintain the request into the, dispatcher will maintain the request into the first in, first out rule, right? Dispatcher queue. There is a queue. It will maintain the all the request here. Then which work process is available, dialog work process, your request will be allocated to the that work process here, right? So then immediately it is assigned to the work process here. Then there are the buffers in SAP systems here. So let me write it here. These and all the shared memory here. In the shared memory only we have the buffers here. Shared memory. So we have the buffers like role area. This is the user details like default settings, user ID, passwords. So that will be stored in this shared memory here. This is called the role area. This called the role area, and this is called the user context. Let me write it here. This is called the user context here. User context here, right? So role area, user context here. So role in user context here. Normally we will call it as the role in user context. In, role in, role in. Okay, role in. So what will happen? Then here we have the buffers are there here. Of the buffers, application buffers are there here in the buffers. So calendar buffer, name tab buffer, CUI buffer. They are the buffers are there in the SAP system here. They are the buffers are there here, right? They are the buffers are there in the SAP system here. Buffers, normally we will call it as the buffers here. So buffers. So this is, we will call it as the buffers and role area. So then what exactly will happen here, right? Whenever now the user request flow, you can see it here. Okay. Now user request flow will you see this and all the, so SAP in the SAP level, this will happen here, right? So whenever user click, once the user click from SAP system from SAP logon pad, so then the user request forwarded to the dispatcher. This is the step number 1. This is the step number 1, right? Then dispatcher will maintain the all the request into the FIFO order, first in, first out, like that it will maintain. This is the second request here, request number 2. So which means first step. So whenever you click the SAP logon pad, whenever you click the SAP logon pad here, then your request will be dispatcher will maintain the request, then will maintain the will in the order, then will assign to the work process here. Step number three here, what will happen here? So as per the user request, the particular work process is assigned to the user. So dispatcher will assign the request to the available dialog work process here, right? Whenever user login to the dialog work process is assigned to the user, then user is assigned to the here. Then once user is assigned to the dialog work process, then the dialog work process, then user authorization, user current settings are rolled into the work process, which means so once it is assigned to the task handler, the task handler will check the whether this user context, user details are correctly maintained or not, whether it will ask the user authorization, then that settings are rolled in, that settings are rolled in here, right? So then what is user authorization? User context settings are rolled into the work process that is in the shared memory. So it will be rolled in. The user context, user authorizations are rolled in here. Once the dialog step is executed, then once the dialog step is executed, then what it will do, it will check the data. Once the user authorization is okay, then once it will check the in the buffers whether the data is available in the or not, it will check the buffers here. This is the step number 4. Then this is the step number 5 here, right? So first user validations, okay, done. So then it will go to the step number 5. So step number 5 here, the work process, it will check in, it will find the data in the buffers. If the data find in the buffer, then there is no need to retrieve the data from the database level here. Then response time is improved here. This procedure, this is called the hit ratio. But because directly it is hitting the buffers here, right? Then hit ratio here. If does not find in the database buffer, then it will go to the database process is called the miss. Hit and miss. Miss means it is not there in the database, that we will call it as the miss. So hit ratio always be higher than the miss ratio. That will be improved. That means if the data is in the buffers, then your response time is improved. If not there, then it has to go to the database level. So then it will go to here. Then here, so then it will go to the what it will happen. There is a database here. So this is the database here. Suppose example, this is the database here, right? This is the database here. In the database, there is a data. First of all, it will check the data. Then it is not there in the database level here. Then your request will assign to the task handler, will assign to the screen interpreter. So the screen interpreter, it will be assigned here. Then it will interrupt the screens here. It will assign to the ABAP interpreter. ABAP interpreter means it will convert the your language into the ABAP language. Then it will assign to the database language. Then database will convert the your request into the SQL format. Then immediately it will assign to the your request to the DB. DB it will go to the DB here. It will go to the DB. It will pull the data from the database here. It will pull the data from the database level here. It will pull the data from the database here. Then what will happen to the data? Requested data is queried from the database level. Then once the process is complete here, the results is sent back to the result is sent back to the user here, right? Where the user is here, in the here the user is, it will send back to the user here. At the end of user data is removed from the shared memory. At the end, user data will be removed from the shared memory here. User data means the user settings and everything will be assigned to the here. It will be assigned to the here. That we will call it as it will store into the user buffer. That is called the rollout. This is called the roll in user context. This is called the rollout. When the user logging out, then it will temporary, it will store the data into the user context. Then it will one copy of data will be stored to the give to the user. Then same copy of data it will be stored into the buffers and everything here. right? This is what it will happen here. Suppose example, if you see here similar, if you replicate the same thing here, whenever you click on from the SAP logon pad here, immediately it will assign to the dispatcher. Then dispatcher is checking the dispatcher. Then dispatcher assigned to the then dispatcher assigned to the work process here, right? Then work process, it will assign the task to the your request. Then it will check the first user validations here, right? Yes, it is checking the user validations and everything here. Then once the user validations are done, then that is called the role in user context here, which means once the user is assigned to the work process, then it will check the user authorization. The current settings are rolled out into the work process here in the shared memory to access the user data, right? Once the dialog step is executed, once you execute the steps, then after that, up to here done. After that, user is assigned. So after that, if you execute something here, suppose example, uh, if you execute something here, mygo. So then what it will do, it will check whether the same data is available in the buffers. The step number 5, it will check in the user buffers. If not available, then it will interrupt your screen's language, convert it, and it will take into the database level. It will query it. Then it will give the response back to the user, and one copy of the data will be stored into the here. One copy of the data will be stored into the here. See, so this data, whatever the data I'm executing, this data not exist in the buffers, application buffer. This is the first time we are executing the transaction code. So it is compiling. This is the goods. This is a goods movement related transaction codes here. So it is compiling. See, it is compiling. So we can see what is the response time, how much response time it is getting here. See, all the programs in the backend, it is compiling here. So it is not exist in the buffers. Then immediately it went to the here. Then see how much. 68,000 and 68,000 milliseconds. Response time is the 68,000 milliseconds, right? So now what will happen again? You execute the transaction code here. Why? Because one copy of data, it will be stored into the buffers, right? When you execute it here, immediately you will get the results, right? Then what is that now? So 813 milliseconds only, 68,000 and 813 milliseconds here, right? Then it will is improved. Response time is improved. Why? Because first it will check in the buffers whether you are requesting the data is available in the buffers or not. If nothing, then it will go to the database level. It will pull the data from the database table level. It will take some time. Then it will give you the results back to the user, and one copy of the data will be stored into the buffers as well. Right? So this is the allocation. This is the how the logon process will allocates here. Right? So in this way, the shared memory is there. These all are there in the shared memory only, right? In this way, this all the types, all the memories are available in the shared memory only here, role memory. So these all are there in the shared memory. Why? Because shared memory, so it is used by the all the work process. It's not the user specific, just it's for the all the work process will use the shared memory here, right? So extended memory, then extended memory over, then it will go to use the private memory here. When the private memory means last memory area, then immediately the work process will go to the, so when the work process are running in the private memory, then your system will suffering from the memory. Anytime it will go down here. So that will happen in the systems. We can see it. Your system response time is to improve. The buffers should be always so higher value. The buffer utilization should be always in the higher value. Then only your response time will be increased. Response time will be increased here, right? So you see here the memory areas, extended memory and heap memory here. So these are the high memory areas here. They are the parameters to control this memory areas and everything. They are the parameters are available here. Yeah, you can see here. So parameters. This will control the above heap area dialog work process related to maximum heap area. So non-dialog 0 and means unlimited. Then total, this is the total, it will use it here. Heap limit, this is the limit here. So then, so we have the so EM means extended memory related parameters, initial size. This is the initial size of the so extended memory. So suppose like if you want to increase it, then you need to change this parameter value. You need to change the value of this parameter here. But nowadays, we no need to change any parameters here. So here there is a one setting that there is a one parameter that called the PHYS mem size here. This will zero memory management here. The new concept that is called the zero memory management ZA. So Z zero memory management concept SAP introduced it. You don't need to worry about the all the parameters and everything, how to change it. Just one parameter that is called the PHYS and for mem size. If you change this parameter value, then automatically remaining parameters values will be increased. So that is called the zero memory management here. So if you change, why? Because all the parameters will depend upon this parameter, this memory area, this parameter only. So if you change this value, automatically, so everything will be changed here. Everything will be changed here. So see here, PHYS mem size. This is the physical memory size. So how much memory 20 GB you allocated. Then based on that, so you will be allocating to the 20 GB to this SAP instance here. So that is the this physical memory. Physical memory means RAM memory. This much of memory you allocated. So if you limit this parameter, if you increase it, then automatically remaining parameter values, buffers, the values, everything will be increased here automatically. You don't need to do anything. So that parameter value will do the all the increases and everything here. So that's the reason it's a kernel dependent parameters. So that's why we have SAP introduced into this zero memory management concept here. So previously we have to manually do the changes and role changes, manually calculate it. There are a lot of groundwork we have to do it previously. But nowadays you no need to do anything here. Automatically system nowadays no need to do anything. Automatically system will do the changes. System will do the changes and everything here. System will do the changes here. This is the goods, the material, goods related request here. So functional will use it here. Material MM, material management team will use this functional transaction codes here. Okay. Any questions, anyone? Obviously, the memory management is the one of the confusing topic. So only remember that one. How the dialog work process will use the Windows and non-Windows level. How the non-dialog work process will occupy the Windows and what is the difference here. Only non-dialog work process, Linux level, it will use the private memory, then extended memory. Remaining and all the same. Only this procedure is different. Remaining and all normal extended memory. If this is full, then remaining memory here. Right? Then that is the one. Okay. So that is the memory management. The next one, let me explain.
Sir, I have doubt.
Yes.
When you transfer to external memory to private memory, if private memory is full, system is down, what will we do?
So we need to restart the system. System is down. What will happen?
No, no.
System is down. All the user sessions will be killed. Then we need to
Okay.
clear the. We need to stop. When the system is stopped, all the buffers and everything will be flushed out. Again, we need to start the assembly system. But we need to check which user caused the high memory consumption. If you check the work process logs in the work directory, you will come to know the some information. Then based on that, we can limit the memory areas and everything.
based on the zero memory management, if we can use.
Yeah, that we can use it. Nowadays, in the latest kernels, we all are using, right? So definitely it should be that zero memory management only. If you in your system, in your real-time system, check any other these parameters. All these parameters will depending upon the formula. The formula will depending upon the this memory size only. So in case if you increase it, automatically this all will be increased. You don't need to manually do that one. So if you are using the latest 753, 754 and the latest kernels, it will use the zero memory management only.
Okay. If we have lesser kernel version, means we have to upgrade to recent kernel versions in that time.
Yeah, on the time this will automatically adjust it. We no need to do automatically. These parameters will be infused as part of the kernel upgrade. These parameters will come. So in case your system is unable to upgrade it, old kernel version only it's stabilized, you are not operating system also not updated, then you are not, I mean, that time we have to manually calculate it. Okay, this is the main area, 20 GB this one, 10 GB this one, 10 GB this one, and the remaining 5 GB this one. We need to segregate it. Like that, we have to segregate the options. So like that, we have to segregate it. But to avoid these calculations and some type of wrong calculation, system performance will be affected. That is the reason SAP in the latest kernel versions they have introduced the zero memory management related parameter, which means one parameter, this physical parameter, one parameter will control the all the memory parameters and buffer settings and everything. So this parameter will control it here.
Okay.
So the next one, let's talk about the kernel upgrade. Okay, we have 740, 20 minutes left. Okay.